Vomisis criteria or criteria. Another word for Vomisis criterion is maximum. You can see this term also, maximum distortion energy. So if you see this term, right, it's also the same as Vomisis criteria. Oh, by the way, I've uploaded the diagram for one of the questions for the homework. Okay, so I do apologize that I did not upload the diagram earlier. But at least 40 people have not seen the diagram and finished the homework. Okay, not funny, but anyway. Right. Hey, what is due today? Is it? Okay, I'll do you a deal. If my course evaluation has more than 75% homework, the last homework, everyone get 1%. How's that? Hey? Okay, so encourage all of you all to do the course evaluation. Okay, so it's a free gift. Okay. Right. Everyone say it's not necessary. I have enough marks. Right. So from here, what is given to us? Daniel, you better tell your friends to do the evaluation, Daniel. If they don't do it, I know it's your friends, okay? Diameter is what? Yes. What? No, I'll get myself burned. Diameter is equal to 1.5 inch. Make friends, talk to them. Stress yield is equal to 42 times 10 to the power 3 psi. Some of you might say, my friends are all here. I know. And P is equal to 60 times 10 to the power 3 what? psi. Okay. So we are going to apply the maximum distortion energy. And it's not more difficult than Tresca, okay? So what we are going to do is we are going to find what is our stress A squared minus stress A stress B plus by stress B squared. We have to ensure that this is lower than our stress U squared. That's the criteria. That's simple. Okay. So we have to determine the principal stresses. Okay, principal stresses with 3D mole circle. Okay, we have to do 3D mole circle. Okay. So why we have to use 3D mole circle? Okay, we have to ensure that stress A and stress B used are the maximum and minimum stresses. Okay. Tomorrow I'll buy your Tiger beer. It's beer from Singapore, where I'm from. And it tastes like Tiger tea. It's that bad, okay? But I want you to try it, okay? So that you won't get drunk. So if we were to now, right? So if we were to now sketch, so this is my, if I have to draw a transformation X, okay, Y, and this is our Z, okay? So if we were to look at, we have to do what? Failure analysis first. But the failure analysis is very straightforward. Okay. So if we were to look in the XZ plane, right? And if we were to look at the cross section, remember we did this before, and then we draw our center line. So this is our element I, element J, element K, and element L. And if we look at the loading condition over here, so loading condition, we have an axial load. Now in the exam, you don't need to do this. I'm doing this because I'm teaching you. Okay, in the exam, you don't do this. So if we were to look at the loading condition, we know that we have a stress Y is equal to Py over A. And then we also have a what? We have a shear stress. The shear stress is equal to Tr over J, right? And if we were to look at element I, element J, element K, and element L, can someone tell me where failure will occur? Is it element I, element J, element K, or element L? Anyone? All of them C minus Py over R, or over A. All of them C Tr over J. Where will failure occur? It all depends on where has impurities. Does not matter which element you pick. So I put down here, does not matter. Okay, does not matter which element is selected. Okay, so you can pick I, you can pick J, you can pick K, you can pick L, does not matter. Okay, so from here, I'm going to copy this diagram. We can more or less sketch the stress state of the element. Okay, so this is Y, X, Y, and Z. So this is A of X. Okay, so if we were to pick an element, okay, so let's say we choose an element somewhere around here. Okay? So if we were to sketch that element, we know in this element, you have a load coming down. This is your stress Y. And because of the shear, the direction of the torsion, this is the surface, and this is your element. Okay. So this is your stress Y, and this is your shear YX is equal to shear XY. So from here, we are going to sketch our 3D mold circle. Why we sketch our 3D mold circle is to ensure that the stress A and stress B that we use are the maximum and what? Minimum numbers, okay? So this is our point X. So you guys seen me sketch this so many times, okay? So this is our surface X, our Y, and this is our Z. So when we sketch this out, Okay, we know we're in the compression range. Element rotate clockwise, anti-clockwise. Okay, so we know that our normal stress Y, or normal stress Y, yeah, no, normal stress Y is somewhere around here. So this is your normal stress Y. And we know that at zero normal stress, this is our stress X and our stress Z line. And then we have to sketch our shear. This is just a sketch. So from here, we know point X element will rotate in the anti-clockwise. So this is our point X. Over here is our point Y. Over here, this is our point Z. Okay, so when we sketch our circle, we realize that what? The bigger circle belongs to our XY plane. So today we draw this a lot of times, right? So now we know by using the XY data, right? What we can determine, we know that this is our stress A and this is our stress B. Because if we were to construct the other two circles are the what circle? Smaller circle. Tomorrow, if you can bring your own cup, I might not have enough beer to go around. And don't tell security I'll get fired. Literally. 2, 4, 6. If I got fired, if I see who will call, I have my suspicion on who will call the security. It might be Evans or Daniel. Daniel, I'm going to miss you. Over my dead body, he says. Right? So now you can see all the 3 circles over there. Okay. And that's your stress A. So the next thing we need to find is our stress A and stress B. Our stress A and stress B value. Okay. So do you all know what we are trying to find out here? We are trying to find the what? The torque. Okay. The question wants us to find the torque. So we have no problem with normal stresses, but we are going to have some problem with what? Shearing stress. Okay. So let's get some things out of the way. So tomorrow we have more time to drink. You guys think I'm kidding, I know. So stress Y is equal to minus Py over A. Okay. So this is equal to, the normal stress is equal to minus 60 times 10 to the power 3 pi 0.75 squared, pi r squared. Okay. So this will work out to be what? This will work out to be 60 power 3 divided by shift pi divided by 75 once, twice, 33.953 times 10 to the power 3 psi. Okay. So we found our stress Y value. Now we cannot determine our shear because shear XY is equal to what? Is equal to TR over J. So for this case, we don't know our T, or T is our unknown. This is what we want to determine. Okay. So that's where we have to apply Tresca or Vomisis criteria. Okay. So from here, we know that stress A and stress B will be equal to stress average, right? Plus or minus the radius of the circle. R is the radius of circle. I'll continue tomorrow. Please ensure to do your course evaluation, and I'll see you tomorrow for our last class.